Hey, fifth grade, we're going to look at the morning work for May 4th through the 8th, okay? So Monday number 1 says write the following number in expanded form, and then here's our number. So for expanded form, we're just going to list the value of each digit and then add those together. So I have 70,000 plus 5,000 plus 300 plus 80 plus 6. And if that's something you struggle with, you can just take the digit and then replace everything else with a 0. So 70,000, 5,000, 380, and then 6 all added together. Monday number 2 says evaluate how many fluid ounces are in 3 pints. So remember, there's 2 kinds of ounces. If we're talking about weight, there's 16 ounces in a pound. But if we're talking about fluid ounces, we're talking about with capacity. So we're thinking about the fact that there are 8 ounces in 1 cup, and then we need to figure out how many there would be in 3 pints. So the easiest way for me to picture this is to think of the big G, and I know that in the big G there are 4 quarts. And I know that each quart has 2 pints in there. Okay, so if I have 3 pints, 1, 2, 3. So I'm just going to erase this part. Okay, and then I'm even going to erase this for right now. So I have 3 pints, and I know that in each pint there are 2 cups. So if I draw that, 2 cups, basically I have 1, 2, 3, 4, 5, I have 6 cups. Okay, so then I need to decide how many ounces are in those 3 pints, or 3 pints is the same as 6 cups. So I'm just going to actually write this under here. Okay, I know that every single cup has 8 ounces, so I could say 8 plus 8 plus 8 plus 8 plus 8 plus 8, or 8 times 6, which is 48 ounces. So in 6 cups, which is the same thing as 3 pints, there are 48 ounces. Okay, 48 fluid ounces. All right, Tuesday number 1 says Jeff wants to buy a pet moose for his favorite teacher. Oh, I'd love to see a moose. I'm not saying I'm his favorite teacher, but I would love to see a moose. The moose costs $25.99, and Jeff has already saved $14.78. Jeff's friend Gina gave him $10 to add to his moose fund. After adding Gina's donation to the money Jeff already had, how much more money will Jeff need to buy the pet moose for his teacher? So this is definitely a multi-step problem, and you can really view it 2 different ways. But this is what I did. I thought of how much we need and how much we have, or how much Jeff has. So the total cost for the moose is $25.99. So that's how much we need. Okay, and then so far Jeff has saved $14.78, and then his friend Gina lovingly gives him $10. So we're actually going to add that to what he has. Okay, so that would mean he has $24.78 now. Okay, and then I want to see the difference because we want to know how much more money he needs. So then we're going to subtract. Now you could have worked backwards. You said it should have, you could have said this is what he needs, and you could have subtracted what he has and then subtracted what Gina gave him, and it's going to be the same thing. But this is what he needs, this is what he has, so I'm just going to find the difference. I'm going to subtract those 2. Okay, so I know that when I add and subtract decimals, my decimal can just come straight down. That's why it's important to line every digit up and to line up the decimals as well. 9 minus 8 is 1, 9 minus 7 is 2, 5 minus 4 is 1, and 2 minus 2 is 0. So he's almost there. He just needs $1.21 more to get that beautiful moose. Tuesday number 2 says, Sydney and Rick are having an argument. Sydney says that there are 1,000 millimeters in a hectometer, but Rick argues that there are 100,000 millimeters in a hectometer. Who is correct? Okay, so we have Sydney says there's 1,000 millimeters in 1 hectometer, and then Rick says, there's 100,000 millimeters in 1 hectometer. Okay, make sure I've got that correct. Okay, so the good thing is they're both talking about hectometers and millimeters, so we're just going to convert from hecto to milli or milli to hecto. Since they're both talking about 1 hectometer and that's the thing they agree on, that's the way I'm going to do my conversion. So I have hectometers here. Now remember, you can think of it to remember as King Henry died by drinking chocolate milk. And then our prefixes are kilo, hecto, deca. Then we have our base, which is going to be meters, liters, or grams. And then deci, centi, milli. Think of that vocabulary that we watched a lot of times, and that kind of helps you remember it. So we have 1 hectometer, and we want to know how many millimeters this is. So to convert from hecto to milli, I see that I would move from hecto to milli. I would move 1, 2, 3, 4, 5 places to the right. So I'm going to start with my decimal because it's a whole number, so this would be my decimal, and I'm going to move it 5 places to the right. So 1, 2, 3, 4, 5. And every time I have one of these blank spots, I'm going to add a placeholder. So now my decimal would be here, which keeps it a whole number. So basically I can see that there are indeed 100,000 millimeters in a hectometer. And the question just asked you who is correct. So the person that said that would be Rick. So Rick is correct with that conversion. Okay, Wednesday number 1 says find the product of 9/16 and 2/4. Okay, so if I'm finding the product, that means I'm the answer when I multiply. So I'm going to multiply these 2 fractions. When I multiply fractions, I can just multiply straight across. So numerator times numerator, or 9 times 2, and then denominator times denominator, or 16 times 4, which is 18/64. Now, that is a correct answer. That's a correct amount, but I want to simplify. I want it in the simplest form. So I have 18/64, and I know that they're both even numbers, so I'm going to start and divide by 2. Remember, whatever I do to the top, I need to do to the bottom to make it fair. So if I divide my numerator by 2, I also have to do that to the denominator. 18 divided by 2 is 9. 64 divided by 2 is 30. 64 divided by 2 is 32. Okay? So I know, I'm trying to see if I can simplify anymore. If I think of the factors of 9, the numbers that multiply together to equal 9, I have 1 times 9. 2 will not evenly divide into 9. I have 3 times 3, and then those are pretty much the only factors. So I can divide both of these by 1, but I'm going to have the same answer. I can divide 9 by 3 without a remainder, but if I divide 32 by 3, there's going to be a remainder. Same thing with 9. I can divide 9 by 9, of course, to get 1, but 32 divided by 9 is going to leave me with a remainder. So the simplest form for our answer is 9/32, or 9/32. Okay, Wednesday number 2 says find the volume of the figure. And so they've got a rectangular prism, so I know that to find the volume of a rectangular prism, I'm going to use the formula length times width times height, or base times height, but the base is really just length times width. Okay, so for my dimensions, my length is 9 2/10 inches, my width is 3 5/10 inches, and the height is 8 1/10 inches. Now remember, it doesn't matter if you have them in a different order. It's okay because I could turn that box on the side and say, oh, now this is the length or this is the height. It doesn't matter. If you're just multiplying, the order does not matter. PEMDAS is when we have multiple operations, okay? So I'm going to multiply just one step at a time. So I'm going to start with 9 2/10 times 3 5/10. Of course, I can estimate, and 9 times 4 is 36, so it should be close-ish to that. 9 times 2, or 9 2/10 times 3 5/10. I'm going to ignore those decimals and just multiply. 5 times 2 is 10. 5 times 9 is 45. 46. I need my placeholder. Don't forget your placeholder. 3 times 2 is 6. 3 times 9 is 27. I can add a placeholder. Okay, so this is my answer, and then I'm going to place my decimal. I have two digits after the decimals, so my answer will have 2 digits after the decimal. And I estimated 36, so 32 and 20 hundredths is pretty close. Okay, I'm going to take off this last 0. It's not really changing the value. So now I have 32 and 2/10, and then I'm going to multiply that by 8 and 1/10 to finish out the problem. Okay, making sure you can see that. All right, 1 times 2 is 2. 1 times 2 is 2. 1 times 3 is 3. Don't forget your placeholder. 8 times 2 is 16. 8 times 2 is 16 plus 1 is 17. 8 times 3 is 24 plus 1 is 25. And then I'm going to add those partial products. Okay, whoa. That's a 2. I'll fix that in just a second. 26082. Again, I have 2 places after the decimal, so my decimal is going to go right here. And I could also have estimated beforehand, 32 times 8, and I'll see what my answer should be close to. So my final answer is 260 and 82 hundredths. And I was measuring in inches, so it's going to be inches to the 3rd power, or cubic inches, because I'm finding the volume. Okay, 260 and 82 hundredths inches to the 3rd power. All right, Thursday number 1 says, how many 1/3 apples are there in 4 whole apples? I've got my beautiful artwork here. I have 4 apples. I want to know how many 1/3 size pieces there are. So I'm going to split each apple into thirds. Well, okay, hang on. That was completely wonky. Let me try this again. Oh my goodness. Okay, that's a little better. Okay, y'all know my skills with artwork. Okay, so I have a third, a third, a third. So in this apple, there are 3/3. In this apple, there are 3/3, 3/3, 3/3. So if I add all these pieces together, I have 12 third size pieces, or 12, okay? Now, another way to think of that with an algorithm would be, I have 4 whole apples, and I want to know how many thirds there are, how many groups of 1/3. So really, I'm dividing, which feels a little weird because when we did it this way, we were adding or multiplying, but the way the problem is, I'm taking 4 whole pieces and I'm splitting them into pieces the size of 1/3, okay? That's why sometimes drawing a picture helps. If you're not sure about which operation to use or the algorithm, then a lot of times drawing a picture will help with that, okay? So then when I divide fractions, I use keep, change, flip. So I'm going to make this represented as a fraction. So instead of 4, I'm going to say 4 over 1, which is the same thing because 4 divided by 1 is 4. So then keep, I'm going to change this to multiplication, and then I'm going to flip 1/3 to be 3 over 1. And then I multiply straight across. 4 times 3 is 12. 1 times 1 is 1. and 12 divided by 1. Remember that the fraction bar means to divide. 12 divided by 1 leads us back to 12. So the answer is 12. Okay, last one, Thursday number 2 says, Jake has to read a 121 and a half or 5/10 page book in 4.5 days. If he wants to pace himself and read the same amount each day, how many pages does he need to read each day to finish the book in 4.5 days? Maybe you've done this in real life. I know I have. If I'm trying to finish something like a book in a certain amount of time, a lot of times I will pace it out to see how many days I want to take to finish the book and how many pages there are, or how many pages I have left. So what we're doing is dividing this book over a certain number of days. Okay, so I'm starting with 121 and 5/10. And he's splitting that over 4.5 days. Now, we know that when we divide with decimals, we need a happy whole number divisor. So to make this a whole number, I would really multiply by 10 or move the decimal one place to the right. And when I do that, I'm going to have a whole number. So I really just have 45. But then, of course, we don't want to leave out the dividend. That little decimal gets jealous, like we talked about. So if I multiply this number by 10, I'm going to multiply this number by 10 and move the decimal one place to the right as well. Okay, so if I moved it, now I also have a whole number. I have 1,215. I'm just going to scoot it over a little bit. Now remember, your dividend does not have to be a whole number. If you move this decimal and you move this decimal, and maybe, if it was a different problem, say my decimal ended here, that's okay. I just bring it straight up to the quotient. But you have to have a happy whole number divisor. Now, in this case, it just worked out that we have 2 whole numbers, and that's okay. So now I'm going to divide. 45 won't go into 1 or 12. It will go into 121, or I can take out, groups of 45 2 times. Can you see that? Yeah, kind of. Okay. 2 times 5 is 10. 2 times 4 is 8 plus 1 is 9. So then I'm going to subtract. Okay, I get 1, and then 12 minus 9 is 3. So then I'm going to bring down my next digit, which is a 5. And I just kind of guessed and checked and played around. Hopefully that's what you did too, or that you just kind of reasoned in your head. I knew that 2 groups of 45 was 90, so I knew 2 more groups would be 90 times 2 or 180, and I just kind of went from there. But you should get 7, and then 7 times 5 is 35. 7 times 4 is 28, plus 3 is 31, so it actually works out exactly perfectly. I don't need to add back a decimal or a placeholder. So the question says, how many pages does he need to read each day to finish the book? He needs to read 27 pages each day, and he'll finish in 4.5 days. Okay? See y'all. Hope you're doing well.